Good morning. Welcome to stream. My name is Dr. Rachel Tapman, and my YouTube channel is for anybody who cares about language technology and other people. And today we're going to talk about data. And I just want to give you a really good understanding of how much data you need for different types of NLP projects, and also how you can adjust a project depending on how much data you have. And I want to keep this pretty tight, so I'm gonna not answer anybody questions in the chat until the end, but if you have questions, feel free to ask them and we will get to them at the end. So let's hop right in. How much data do you actually need for NLP projects? And the answer is, it depends, which I don't think is a surprise to anybody, right? There's a sort of the joke that, you know, every senior engineer is going to answer "it depends" to every question. And I think my last title is actually staff, so yes, it does depend, but we're going to talk about what it depends on, because I think it's not very helpful if I don't give you the additional information, right? So what does it depend on? First of all, what do you want to do, right? What is your task? How is your task structured? Different types of tasks are going to require more or less data. How you want to do it, so the approach that you are using, different approaches have different levels of data need to do it. And finally, what you can get, right? So you may have designed this perfect, wonderful, beautiful project, and then you get to talking to the people you're trying to get data from, and it turns out you can't get as much as you want. So before we get going, I think it's helpful to have an idea of the realistic range of amount of data that different projects have, right? So none. On that side. That's actually pretty realistic. So if you were writing a regular expression for something, you don't really need data to write that regular expression, right? You may need it for testing, but if you understand the pattern that you're trying to capture, you don't need a lot of examples of that pattern to learn it, right? In the exporting process, my spacing has sort of messed up. And then on the other end of that spectrum, you have things like the GPT-3 corpus, the corpus used to train GPT-3. I know it's not the largest model out there, but I think it's a helpful touchstone because I feel like most people have heard of it. And they used a corpus of about 500 billion tokens. So a token is the output of a tokenizer. In English, you can talk about that more or less being equivalent to words. In languages like German or Chinese, you're going to have to probably be a little bit more clear about what tokenization scheme you're using to determine what that means. But for English, it's going to be words. And then in the middle, there's a lot of room, right? So just for your reference, hey, Makalala, 1,000 tokens is about a 4-page essay that is double spaced. 1,000,000 tokens is the rough size of the Brown corpus. So if you've been in NLP for a while, you'll be familiar with the Brown corpus if you work on English. Very widely used corpus. And then the completed works of William Shakespeare that we have, obviously there's some lost works, is around 800,000 tokens. So that should give you a rough idea of sort of the range of corpus sizes, from the very high end, 500 billion, to, you know, one essay, which would be about 1,000. Alexi. All right. So first of all, what is it that you want to do? This is going to determine how much data you need. And in general, different tasks require different amounts of data. And this is a very broad guideline, but generally, if you are trying to assign something to a known set of classes, right? If you're trying to do classification, or if you're trying to predict a measurable thing, regression, generally you will need less data for classification and regression tasks than you will for things like generation tasks, or potentially, depending on the structure of your data, even things like unsupervised, not unsupervised. Yes, unsupervised learning, like clustering, right? And that's because in classification tasks, you generally have a labeled corpus, so you have an idea of the, the ground truth of the distribution of those classes and sort of any imbalances, and you can adjust for that. Whereas if you're doing an unsupervised clustering, then you don't know the ground truth, even number of categories necessarily. So if you take a task that is simpler to learn, right, it is easier to detect whether something is a restaurant review or a other thing that you would review, a movie review. It's easier to separate things into restaurants reviews and movie reviews than it is to write a restaurant review or a movie review, right? And generally, the more complex a task is, or would be for a human to do, the more data you're going to need. And then also the scope of your data. So I talked a little bit about the internal structure of your data. All language data that is usable as training data, I would argue, is produced by humans, and humans use language for a lot of different things. So domains is a big one. Is this all social media data? If it's all in a single domain like that, you probably need less data. If you have a combination of social media data and research papers and court cases and sermons, that's very heterogeneous. You're going to need more examples to be able to capture the variation within that very, distinct group. Topics, right? So what is the text about? If you have a very narrow set of topics that are repeated a lot, you'll need less text. If you have a wide variety of topics, you'll need more, just to have a better the better ability to sort of trace that envelope of variation, because of course you're sampling, you don't know how representative your samples are, etc. And then also types of users. So who is producing this data, right? If you have a corpus of social media data from, let's say, politicians from a single party, that's probably going to be fairly heterogeneous. But if you have social media data that's, about dogs, right, you're going to have a large variety of types of users. You may have users who are pretending to be dogs, so they'll sort of have like this, hello, cheeseburger, please, a sort of very stylized type of language user. You might have vets, you might have dog trainers, you might have dog breeders, you might have people talking about their pet dogs, and those types of users are going to use language in very different ways. So if you have a wide variety of types of users, you're going to need more data. So in general, the harder your task is to do, the sort of more creative, I guess, the task is, and the more variation there is within your data set, the more data you'll need in order to be able to, A, have enough information for that task to be learnable, and then B, to be able to represent, the variety of data that your system will see. And I would just, this is just like a little cautionary tale for you. So when you're working on a new project, particularly, if you're a contractor or you're working for, a company that's just getting into the NLP space, a lot of news stories are about like the London Bridge, right? This is one of the London bridges. I don't know which one. And there's a lot of sort of discussion, and in the sort of the general zeitgeist, I guess, of really, really big models that are very general purpose, right? So if you're going across the London Bridge, you could drive, you could take a bike. I'm guessing here, I'm not actually that familiar with this bridge, but imagine, right? A very big bridge is going to be able to handle, trucks. It might be able to handle trains. I don't know. I think the Golden Gate Bridge, there's trains on the lower level, if I remember, right? So there's a lot of variety of types of traffic that it can handle. It's very big. It's very expensive. It took a long time to build. And if that's what you need, right, then by all means, that's a good investment. But what if you actually need like a footbridge, right? You have one type of user who's trying to do a very simple task in a single domain, in a single topic. And if you are, let's even just say that you're trying to do like a first round of, looking at the marketing pipeline, you're getting a lot of emails and you're trying to figure out which of these are from people who have businesses, right? So very straightforward classification task. If you try to build a general purpose model for that, it's going to take ages. It's going to be expensive. You're going to need a lot of data. But if you build a very narrow model using not a lot of data, with a very narrow focus in topic and scope, then you don't need as much data, right? You don't need as many resources, you don't need as much time, you don't need as much compute. So I know that it's very tempting, and you will have people in your professional career who come to you and they want GPT-6 and they want you to build it because they read, you know, an Atlantic article about how it's sentient, and they're like, oh, I'll be able to fire a bunch of people if I build this, you know, wonder robot or whatever it is that they think. And part of your job as a language technologist is to help them really figure out what it is they need and what would be a good use of your time and their money, and would actually solve the problem as it exists, rather than immediately going to the biggest possible model. And this may be a challenge, but just be aware it's going to happen. All right, so that was what you wanted to do. The narrower the scope, the simpler the task, the less data you'll need. And now how you want to do it. So even if you have the same scope and the same task, depending on the architecture that you choose, depending on the methods that you're using, you may need more or less data. And also, how much are you building yourself? Are you using anything pre-built? Are you using, you know, an off-the-shelf service maybe? That's also going to determine how much data you need to do a project. So let's talk about approaches first. And again, this is going to be a very sort of high-level guide to help you, you know, have a clear understanding. So here we have a bunch of different types on this side. You have a bunch of different types of approaches, and then on the other side, this is a general rule of thumb, but roughly how many tokens worth of training data I would recommend if you're trying to use this method, right? So for rule-based systems, right, you're using regexes, you're using if-thens, you don't need data, right? Because you're building a rule. You don't need training data because it's not a machine learning approach, basically, is what it boils down to. You as a developer may need to see examples. You may need to work with your user experience folks. You may need to work with a designer to help understand what it is that you're trying to capture, but you don't need training data for it. Moving on, statistical methods. So statistical methods are very, very varied. There's a lot of them. These would be things like, you know, hidden Markov models, you know, your classic finite state automata, you know, any sort of corpus-based technique. If it calls itself a corpus-based technique, it's probably a statistical model. You know, yeah, I would say even things like, you know, non-deep learning word vectors and embeddings, I would call a statistical method if they're not using deep learning to train them. And for that, you need thousands, tens of thousands, hundreds of thousands, in that range number of tokens, in order to have, you know, a fairly reasonable output. They're a lot more data efficient than some of the deep learning methods. And they're also a lot more compute efficient, but they're going to be a little bit less flexible, right? Moving on to sort of like, this is also, by the way, sort of a history of the field. So rules came first, and then statistical methods, and then recurrent neural networks. So, you know, things like LSTMs. When I was in grad school, bidirectional LSTMs with attention were, you know, the architecture that everyone was using. And to train these, I would say you need in the order of millions of tokens, right? So if you have millions of tokens, and also you're not super worried about taking quite a long time to train your model, even if you know, you're not necessarily going to be using as much compute, but if taking a long clock time to train, then maybe RNNs would be right for you, right? And of course, if you do have billions of tokens, I probably wouldn't recommend a recurrent neural network, because even though they seem to be better at capturing some of the structure in, you know, language text data, they don't seem, the big issue with RNNs is that there's a training bottleneck, right? Because they step through the data. So in order to do time 1, you have to have done time -1 and time -2. So you have that sort of temporal structure that you're trying trying to capture, so you have to go through the data temporally, which means that the amount of parallelization you can do is not as much as it is in transformers. So the benefit of transformers is you can parallelize your data, your training process, significantly more than you can with a recurrent neural network. But they have many, many more parameters than a recurrent neural network. And as a result, they require more training data. So if you have billions of tokens and you want to train something from scratch, maybe a transformer is the right choice. I will say that sort of like going top to bottom, these are also, they are ranked by the amount of data they need. They're ranked by sort of age of the field. They're also ranked by expense, right? So rules are going to, at least to build initially, are going to be cheaper, because you're just paying for the time of the engineer who's writing the rules. That may or may not scale as well as a transformer model, let me put it that way. But as you sort of step down here, you're going to need more compute, you're going to need more storage, serving is going to be maybe a little bit more complex. So that's sort of the way that those different approaches relate to the amount of data that you have. And if you have millions of tokens worth of training data, and you don't have a model to tune, right? You don't have something where you can do some additional training of the trained model, I probably wouldn't recommend transformers. I'd probably recommend something like a recurrent neural network. And we'll talk about tuning in just a sec. All right. So, these are sort of how much data you need to train these things, and it's assuming you're starting from scratch, you're doing everything in-house. And I think it's good to know, especially if you haven't been in the field very long, sometimes you have to do that, right? For, compliance reasons, practical reasons, you may or may not even be able to get like Python packages. So just be aware that this is something that may come up for you at some point in the future. However, if you can do some pre-training, then you don't need as much data because the original model has been trained with a lot of data, and your hope is that that sort of warm start is going to provide the model enough relevant information and structure to model that then when you come in with your specific training data and you update that model, it is useful for you, right? And the amount of training data that you need in order to take a general purpose model and make it work for your specific purpose is going to depend on the size of that model. The bigger the model, the more training data. And also how close the original training data was to your target training data, right? So if I have, let's look at an extreme example. If I have, let's say, a transformer that's been trained mainly on English and I want to use it on French, I'm probably going to need to do quite a bit of tuning and more tuning than I would if I wanted to take that same model and also use it for English, especially if I was trying to capture like something that is already pretty well represented in the model itself. And in fact, you may not need to do any tuning if that is that case, depending on the model. So the benefit is you don't need as much data. The downside is the model to start with isn't as specific. Also, you're probably going to need to pay somebody, depending on the type of pre-trained model that you're using. And also, even though you might not need as much data, the backprop is still going to go through the whole model unless you're adding additional layers. And if you're adding additional layers, then the size of those layers is going to be dependent on the size of the original model. I would just say, embeddings and word vectors are pre-trained models, right? They capture, the distribution of tokens in the corpus that they were trained on. And if it's a fairly good fit for what you're working on, they can really get you pretty far. And I think actually Spacey just released a set of very lightweight word vectors. So if you're working in a very lightweight situation, can be a very good way to get the benefit of that sort of warm start without having to provide all the data to have that warm start. And then finally, off-the-shelf solutions, right? So if somebody else has built it and trained it, you don't need data, right? And there are, benefits and drawbacks to this. So one benefit or drawback is that it may or may not be tunable. You may or may not be able to take this model and adjust it to be a better fit for your use case. And if your use case is a pretty good fit for the use case that the original model was trained on, that's fine. It doesn't matter. If it's not, it is going to matter. And this may or may not be able to work for you. Also, just to be perfectly frank, NLP is a field that is moving very, very fast. There's a lot of investment money. There's a lot of companies burning through investment money pretty quickly. And there's a lot of instability in the field. So if you are going to go with an off-the-shelf model, particularly if it's like a hosted software as a service thing, just when you do that, be aware that you are committing yourself to continuing to work with this provider, and that there is instability in the field, and this provider may or may not be there in the long term. And maybe you're just looking for a short-term solution, and that's fine. And maybe it's worth it to you to have that benefit of not having to, train and serve and update and do, security and compliance stuff on the model yourself, right? That may be a worthwhile trade-off for you. And just finally, do your due diligence, right? If you're going to use a model, do as much as you can to figure out what data trained the model. Also make sure that that data was used legally. There's sort of an increasing trend, particularly in the US, of models that were trained with data that was collected illegally being deleted, being ordered by a court to be deleted, which is, if you were using that, right, and if your business is built off of that model, that's going to be an issue for you and your employer. So I'm not saying don't do them. I think that for a lot of cases, they can be, perfectly adequate. And again, they save you that burden of maintenance. They save you that burden of doing your own security. They save you, having to deal with like TensorFlow version updates yourself. But, weigh the pros and cons, right? I feel very senior engineering right now. And then the final thing, so we talked about what you're doing, right? The more complex the task, the more general purpose the task, the more data you're going to need. If anyone comes to you with a project that they want to do that's open domain, I just wouldn't do it. I would just politely back away and be like, find somebody else. It's going to be a pain, and you're not going to enjoy working on it, most likely. So what are you trying to do? How are you trying to do it? The more data intensive the algorithm you want to use, the more data you're going to need. If you're building everything yourself, you're going to need more data. If you are using pre-trained models, you'll need less. If you're using an off-the-shelf solution, you may need none at all. You may actually still need some to tune, depending on the provider and what it is you're trying to do. And then finally, what can you get, right? Because so far we've been talking about this, wonderful fantasy world where we all can get the data that we need, and, we're making architecture decisions and we're making task decisions based on sort of what it is that we want to do. And, as those of you who've been in the field for a while can attest, sometimes, sorry, that was my dog. Sometimes you want to do something and you just don't have enough data to support it, right? Even maybe you want to build a statistical model and the data that you would need to train it doesn't exist. You have to use rules because there is no data, right? So how much relevant data can you get? And I think there's also... I have been seeing a little bit of a trend, particularly in research groups, to collect and release data sets that are not super high quality, right? And by that I mean they contain, language that probably wasn't produced by a human. They may be multilingual, but the multilingual data may be produced by machine translation and may contain a lot of errors. And I would just caution you, wrong data, right? Data that is not relevant to your task is going to result in a model that can't do your task, right? It will result in a model that can handle this low quality data or irrelevant data, which, cool. But if your data that you have is not relevant to your task, it's not relevant to what you're trying to do, that is a waste of time and money and compute. And if you are in a situation where you don't have a lot of data, which, welcome to the club, we've all been there, using a smaller model is probably going to be a better bet than trying to, grab all this irrelevant stuff, shove it in there and see what happens, because what happens is probably not going to be what you want to happen. So just to review, how much data you need depends on what you want to do, how you want to do it, and what you can get. That is, unfortunately, the very real limitation of the field is that if you're using, machine learning data-driven methods and you don't have the data, you got to use different methods, right? And I just want to, a little, I don't know. rocking chair porch moment. I think that as a field in NLP, particularly if you've come to the field recently, there's a lot of excitement about scale. There's a lot of excitement of very big models and very big data. And I would say that that's not an inherent virtue, right? So in my professional experience, not in research, but like working in the field, often you don't have the luxury of scale. You don't have the time, you don't have the compute, you don't have the budget for the compute, you don't have the data, and you are forced to work in this, very limited way if what you, I say limited, I don't know, realistic way, right? Like fantasy worlds are great, but we don't live in them, right? So, when I'm in that situation, I'm like, if only I had, another 100,000 tokens of relevant data, I could do this or that or that. I like to remember just how small the Apollo guidance computer was. So this was what was used to take the shuttle and go to the moon. And if we're talking about, English words, it had the memory for less than 39,000 words, right? Which, if you remember, is like, I don't know, 5% of the total works of William Shakespeare, so not a particularly large corpus. And obviously they weren't doing machine learning with it. It was all, hand built everything, but it worked, right? So that's what I like to think about when I'm feeling a little bit constrained by data paucity or compute limitations, is that, you know what, you don't need it. It can make your job as an engineer a little bit easier sometimes, but it's not necessary. All right, so that is, let's go back. So those are the things that affect how much data you need. And again, in my experience, the sort of range of the actual amount of tokens that you will have ranges from 0 to, a couple million, a couple 100 million. I don't think I've ever been in a situation where I actually had 1 billion tokens of relevant data. So maybe you are in a different situation, but that has been my experience. All right, so I will now go to the questions. Alexi says, what about Bayesian versus frequentist thing on the data annotation versus model complexity? That is a great question. I mean, they both rely on enough data to create okay, so Bayesian versus frequentist. In sort of the ideal situation, you will need a little bit less data for a Bayesian model than you will for a frequentist model, if your priors are useful and relevant, right? So it's just like the pre-trained model. If the pre-trained model is useful and relevant to your task, it's going to help. If it is irrelevant, it's going to hurt. So depending on your priors, you may need less data for a Bayesian method. You'll probably need a little bit more compute. Frequentist methods tend to require less computation because you're not using, you're not sampling the posterior to sort of have an idea of what it looks like, right? Because it's, I have not yet come across a normal posterior, particularly in language data. But yes. Lexi says, in generation versus classification, you need to learn different distributions. I mean, yes, and in different classification situations, you're also going to need to learn different distributions. But I mean, if you think about it just sort of at a very simple level, if the number of classes is less than the number of tokens in your vocabulary, then just sort of like at a computational standpoint, it's easier, right? Like a true false question is easier than a multiple choice question with 10 possible answers, just like at the base chance rate, right? So you have to do a little bit less lifting. Oh, sorry, I just realized I only had top chat on. I may have missed some messages. I did not. All right. So that's all I had today. I hope this was helpful. I want to keep this nice and tight so that it's a quick reference rather than a long rambling reference. Yeah, and don't despair if you don't have that much data. You can use different methods. It is fine. It is absolutely fine. It may not have the same sort of, cachet as using the latest transformer model, but it can get the job done. Folks have been doing it for decades. And, take heart. imagine, the ghost of the Apollo guidance computer hovering over your head like this one, being like, it's okay, I was very small. All right, that's all I have for you today. I want to take a quick second to thank, there we go, all of my wonderful monthly supporters. I appreciate you very much. You help make this channel possible. Thank you. And I will be back on Thursday for our usual coffee chat, talking about, stuff that's happened in the news recently, relevant court cases, legislation, research papers, cool jokes, I hear. So would love if you would join us for that. And otherwise, I will see you around. Thanks so much for joining. Stay safe, stay healthy, and I will see you soon.